So in the given series RC circuit, in how much time will the capacitor be half charged? So that is the question being asked here. So the voltage across the capacitor is Vc of t is equal to Vc of infinity minus Vc of infinity minus Vc of 0 e raised to minus t divided by RC. Okay. So this is the equation for voltage across a capacitor, where Vc of t is the voltage across a capacitor when t tends to infinity, and Vc of 0 is the voltage across the capacitor when t is equal to 0. Okay. So for t tends to infinity, when t tends to infinity, capacitor will act as open circuited. Okay. So I'll draw the circuit over here. When t tends to infinity, the switch will be closed and the capacitor will act as open circuited. So this is Vc of infinity, right? So the whole 50 volt will be dropping across the capacitor. That is, Vc of infinity is 50 volt. So what is Vc of 0? When t is equal to 0, switch is not closed, so no current is flowing through the capacitor. So the voltage across the capacitor at t is equal to 0 is 0 volt. And now coming back to this equation and substituting that, we will get Vc of t equal to Vc of infinity. Instead of Vc of infinity, we have 50 minus 50 minus 0 into e raised to minus t divided by RC. What is RC? 10 into 2, that is 20, right? So this is equal to 50 into 1 minus e raised to t divided by 20. So this is a question, and it is given in the question that what is the time when the capacitor will be half charged. So that is what is asked here. When the capacitor is half charged, the voltage across it will be half of the maximum. So the maximum voltage over here is 50 volt. So the half of it will be 25 volt. So I can substitute that in this equation. That is, Vc of t is equal to 50 into 1 minus e raised to minus t divided by 20, and at 25, that is half of it, equal to 50 into 1 minus e raised to minus t divided by 20. Now we have to find out at what time does this happen. Okay. So yes. Okay. So this is 1 by 2 into 1 minus e raised to minus t divided by 20, and e raised to minus t divided by 20 is equal to 1 by 2, and from here we get t is equal to, take the natural logarithm only, okay, 13.86 seconds. So this is the answer. Okay, now let's do the next question. Assuming that I of 0 equal to 5 ampere, the value of current I of t as shown in the above circuit is, okay, so I of 0 is equal to 5 ampere, that is a current through the inductor at t is equal to 0 is given here, which is equal to 5 ampere. And now in this question, there is only one dependent source and no independent sources are there. So whenever there is a problem like only dependent sources are there, what we should do is we should introduce another voltage, test voltage for 1 volt and current IT, and then find out the Thevenin's equivalent, and then after that we will do the other calculations. Okay, so I am going to introduce the test voltage of 1 volt over here. Okay, I am just going to replace just going to find out the Thevenin equivalent of this circuit. Okay, this circuit, and then after that we will replace that with our equivalent inductor. Okay, so before that we will just find out the Thevenin's equivalent for the circuit. So we'll write this as it is 6, and this one is 2i, right? So the IT current is going over here. So writing the node equation, the voltage over here will be 1 volt itself. So I am writing the node equation. IT current is coming to the junction and is being divided between, this is 3, right? So 1 divided by 3, because 1 is because it is 1 volt over here. 1 divided by 3 plus 1 minus 2i divided by 6, right? So from here we will take the LCM. We will get IT is equal to 2 plus 1 minus 2i divided by 6 or 3 minus 2i divided by 6. Okay. So what is the relation between I and IT? So from here we can see I is in this direction and IT is in the opposite direction. So I can write I is equal to IT is equal to minus I, right, which is equal to 3 plus 2 IT. Instead of I am going to write minus IT. So I'll get 3 plus 2 IT divided by 6. Okay, and we'll cross multiply. We'll get 6 IT is equal to 3 plus 2 IT. That is IT is equal to 3 by 4. Okay, we got 3 by 4. And to find out our RTH is equal to 1 divided by IT. That is equal to 4 divided by 3 ohm. Okay, we got RTH is equal to 4 by 3. And now what, so RTH meaning R equivalent. So then I will draw the equivalent circuit. So this is 4 by 3 and we'll take back our inductor, that is 1.5 Henry. And now we'll see what happens. Tau is equal to L divided by R equivalent, right, which is equal to 1.5 divided by 4 by 3, which is equal to 15 into 3 divided by 4. We will get tau is equal to 1.727 seconds. Okay, and the current across an inductor, the formula is I of t is equal to, for source free circuit. Okay, this is a source free circuit. Isn't this a source free circuit? This is a source free circuit. For source free circuit, the current across an inductor is equal to I0 e raised to minus t divided by tau. Okay, where I0 is the initial current. So I'll write the equation for the current. We have to find out I of t, that is the question. So I of t is equal to I0, it is given in the question that it is 5 ampere into e raised to minus t divided by 1.127. It is not 727, it is 127. Okay, 1.127, or we'll get 5 into e raised to minus 0.887 t. So this is the answer. So with that I am going to, okay, let's see, there's another question. Okay, so the last question in this session is for the network shown below, what is the value of voltage transfer function? That is what is asked here. Okay, to find out the voltage transfer function, you can see there are voltage transfer function means V2 of S divided by V1 of S. I will redraw the circuit and then we will write it in terms of what in Laplace transform terms. Okay, so this is a circuit. This will be V2 of S. Okay, everything in the Laplace domain. This is V1 of S. This will be Ix of S, and capacitor becomes 1 divided by SC, that is 1 divided by S into, what is C here, 1 by 2, right? So it will be 2 divided by S. So I can write this 2 by S, and this will become 2 Ix of S. This will be, inductor becomes SL, that is equal to 1 into S. So this is S and this is 3. Okay, and I will write the mesh equation over here, over this bigger mesh. Okay, bigger mesh, and I'll start from here. It will be V1 of S minus the current going through 2 by S is Ix of S, right? So 2 by S into Ix of S, and this current are joining together. So the current flowing through this will be 3 into Ix of S. So it will be 3 Ix of S into S minus, again it will be 3 Ix of S. That is going for here only. So 3 into 3 Ix of S equal to 0. So V1 of S we will get equal to Ix of S. I am taking Ix of X outside. We will get 2 by S plus 3S plus 9. Okay. And what is V2 of S? V2 of S is the voltage across our 3 ohm resistor. So that is equal to 3 into current through this resistor is 3 Ix of S. So that is 9 Ix of S. Okay, we got a V1 of S and V2 of S. Now we have to just divide it. That is 9 Ix of S divided by this one. That is Ix of S into 2 by S plus 3S plus 9. Okay. So that will be equal to 9 divided by 2 plus 3S square plus 9S. Yes, rearranging we will get 3S square plus 9S plus 2. So this is the voltage transfer function. Okay, so this is the answer. Thank you for listening. Please follow me on Instagram and Facebook page, and also subscribe to this channel. Thank you so much.